5. So I gather that you didn't have difficulties with the first question, but now I have to do everything. So this is part A. So this is 1250 and n is 50. So the first condition, which is condition of independence, 50 is less than 1250, so it's independent. In second one, np1 minus p has to be greater than or equal to 10. So let's calculate that. So 0.6, n is 50 times 0.6 times 1 minus 0.6, which is 0.4. So 50 times 0.6 times 0.4, and I got 12, and it is greater than or equal to 10. So normality is fulfilled. So then the answer is definitely normal, approximately normal, because, and yes, and that's correct. I still have to read this. Okay, so that's incorrect. So obviously it's part B. And I check the answer. Okay. Determine the mean of the sample distribution of p hat. So suppose a number is obtained from a population of size this. Describe the sample distribution. So here I don't have anything else to do but just write 0.6 because the mean is a population with specified characteristic of p equals 0.6. So where's my keyboard? Okay, he's right here. So I have to write 0.6. Is that okay? Any questions on that? Okay, moving on. Determine the standard deviation of the sampling distribution of p hat. So we have to use the formula, which is the square root. So the square, so sigma.
So this was the part I got wrong.
So this is the square, that's okay. P1 minus P divided by N. So that's the square of 0.6 times 0.4, and N to us was given as 50. So careful how you put it in the graphing calculator, because you have these new sophisticated calculator maybe not need some certain parentheses, but I don't trust it. So I put 0.6 times 0.4 and I divide by 50 and close the parenthesis. And I got approximately 0.06928. And now I'm going to look and see what they want. Round to 6 decimal places. 2, 4, even more than that. So 6.92820. So 6246. I have to write 0.069282. Is that what you entered, Sean? Or maybe you have a different problem, by the way.
No, the problem is the same. The answer I got twice, which it probably was just a parentheses issue, was 0.009798, which I just did it again right now and I got the right answer. So it was probably just a parentheses issue.
2, 4,
but I was
6.
using the formula, not getting the right answer, so I wondered if it was something I was doing.
Okay. So be very careful because, again, I don't know what type of calculator you have. We recently got these new calculators. Unfortunately, I broke mine, so I had to purchase one. I don't fully trust it because it's confusing. Sometimes it wants parentheses, sometimes it doesn't. So that's why I always put parentheses. If you have an older version, when you press second and square root, it will automatically pop up with the left parenthesis, but not on this one anymore. So it's confusing. See, if I don't use parentheses, I'm almost sure, or maybe because it's multiplication, but let's see if I get the same answer. It by chance, okay? I would never do that myself. I will always put parentheses because that's me. Do we need to continue with this one?
No, I don't need to anymore.
Okay. So So you don't have any difficulties with this, right? You have to
No.
put it in the normal distribution. So second and so normal CDF from 0.64. See, I'm used with the other calculator with that syntax. Okay, the operator is correct. Mu is 0.6. And sigma, I have to enter it the way I have it here, or like this, to be exact. It's up to you. So since we have enough decimal digits, I'm going to use that. 692,820. And I get, what do they want? Round to 4 decimal places. So 0.28194. Yeah. And then since we did all that, so let's finish it up. What is the probability of obtaining, so that is, what is this? Okay, same thing. Go to second and distribution and normal CDF. But this time we're going from negative infinity, so negative E99. And we stop at 0.52. With the same, it kept the 0.6, it kept the same sigma. And I get 0.1241. How many decimal digits? 4 again. 0.1241. Oh, I was typing up in the air, in the cloud. 0.1241. Okay. Very good question. Anything else? Other questions for me? Anything? Anything? Okay. We promised last time to go to, how do I get out of here? I got it. Okay, this is going. Okay, so last time we did not get the chance to do any from the homework, 10.2. So you tell me now what you would like to work on. Anything from 10.2, and then we'll continue with 10.3. I posted the handout about an hour, something like that, ago. So we have a couple of examples to go through, and then we'll work on 10.3. This is the end of chapter 3, and we're going to have to look at 11 and 12, hopefully before Thanksgiving. All the material is finished, so we can start reviewing. And then we'll have 2 sessions to review for the midterm and 2 sessions to review for the final. Okay, what would you like to start with? Anyone?
Question 7.
Let's start with question 7. When are conclusions said to be statistically significant? I'm going to stop sharing for 1 second because I want to write something down. It's a very good question you picked. Thank you. Statistically significant. We said this a while back, but I want to say it again. The results of a test are called statistically significant if the p-value is less than alpha. Let me write it differently so it's clear. P-value is less than alpha, because this is not clear. It's clear to me, but it may not be clear to everyone, so sorry about that. So when the p-value is less than alpha, the results of the test, so this result implies the results of the test are statistically significant, and we reject the null hypothesis. That's what we call statistically significant. And we're going to talk, it's a perfect question, thank you. We're going to talk about the difference between statistically significant and practical significance. So statistical significance and practical significance. Okay, perfect. I'm sharing again. Okay. So what are conclusions said to be statistically significant? When the p-value is less, when the p-value is greater? No. When the p-value is less than a given significance, yes, that is the correct, but I still have to read the rest. When the power is high, what the heck is that? When neither a type 1 error, no. When the significant, no. So when the p-value is less than a given significance level or chosen by us, we may be researchers tomorrow and we may choose the significance level. Every time the p-value is less than alpha, we reject the null hypothesis, saying there is sufficient evidence to conclude from the sample that we have to conclude that it either changed or whatever the test is, one-tail test, two-tail test. Good. Very good pick. I was going to talk about that already, today. So you already picked that for me. Thank you. Good. Next question.
Number 14?
I couldn't hear. I think I heard 14.
Yes.
Some have argued that throwing darts at a stock pages, at the stock pages to decide which companies to invest in could be a successful stock picking strategy. Look at that. Suppose a researcher decides to test this theory and randomly chooses 200 companies. I have to take notes now. So N equals 200 to invest in. After 1 year, 104 of the companies were considered winners. X equals 104. P hat, if I need it, is 104 over 200. That is, they outperformed other companies in the same investment class. To assess whether the dart picking strategy resulted in a majority of winners, the researcher tested H naught, or the null hypothesis, P equals 0.5, versus the alternative, H1 or HA, as I like to call it, P greater than 0.5, which automatically tells us that this is a one-tail test and it's a right-tail test. Okay? And they said already that the p-value was determined 0.2858 and alpha was 0.1 or less. Okay. Explain what the p-value means and write a conclusion for the researcher. Assume alpha. Okay. Choose the correct explanation below. So, again, a very good pick. Thank you. The p-value is this number. I'm going to have to stop sharing for a second because I need to show something on my paper. So 0.2858. So when alpha is 0.1, and this is a right-tail test, this is the alpha. But 0.2 is almost 3 times as this. So much larger. So let's say this. Everything. This piece. All this is the p-value. So it means that the test statistic coming from the sample is in the non-rejection region. It's right here. This is where Z statistic will fall, right here, this number. That will create this probability, p-value. So it's non-rejection region. So definitely we fail to reject. What does this mean? is that the probability of getting a z statistic here or more is not unlikely. If the z statistic were here, and the probability will be this tiny, the p-value will be this tiny piece here, I would have said the probability of getting this or more is very unlikely. But since I got it here in the non-rejection region, and the p-value is this big area, much bigger than alpha, I fail to reject the null hypothesis, and I'll say this is not unlikely to get a number here from the sample, the next sample, next sample, next sample, to get a number here or more. It's not unlikely. Okay, now I'm sharing, and let's read. So, I forgot one more thing to say. So this is basically 28.58%, approximately 29%, which means 29 out of 100. So it's not unlikely to get 29 out of 100 or more because of the area of the p-value. Okay, now I think I don't have to go back to explain again. So 104 and 200, that doesn't mean anything to us because we are talking about the p-value, and the p-value is roughly 29%, which is 29 out of 100. So the first two have no discussion here. Now the last two, and we have to read them very carefully. 29 in 100 samples will give a sample proportion as high or higher than the one obtained if the population proportion really is 0.5. This is what it refers to, the null hypothesis. This is coming from the null hypothesis. So this is, I'll select it, but I still read, and I need to read this with you. About 29 in 100 samples will give a sample proportion as high or higher than the one obtained if the population proportion really is greater than. No, this is the alternative. This is the alternative. We are referring to the null. And maybe I should share one more time. Sorry about going back and forth so many times. We're talking about this. If this is true, we fail to reject. So it's 29 over 100, not of this. So it's very catchy here. So, sorry again, I have to go back. So we're not talking about greater than 0.5. We're talking about we are rejecting or failing to reject the null hypothesis. So this has to refer to that. It's a very good pick. Thank you. Thank you for picking that problem. Oh, we're not done. Sorry. Because the p-value is large, reject. No, of course not. When the p-value is large, I cannot reject. Small, I have to disregard B and D. They make no sense. Because the p-value is large, correct. Do not reject the null hypothesis. Fail to reject the null hypothesis. There is not sufficient evidence to conclude that the dart picking strategy resulted in a majority of winners. We failed to reject because the p-value is large. Careful, you must read everything because you never know what to expect. Okay? Good, very good.